My dear students, today we will discuss the argument of the complex numbers. Argument of complex numbers. This is called x-axis and this is the real axis in the complex plane. This is y-axis and it is called an imaginary axis in the complex plane. So this diagram is called Argand diagram. If we take any point x, y in the Argand diagram, if you join this point P to the origin, this OP line is called Z. Z is equal to x plus IY. So any complex number is represented in the complex plane, that is Argand diagram, like in the given figure. Now this line makes an angle theta measuring with the positive direction of x-axis and going anti-clockwise. This angle theta is called the argument of the complex number. Now tan theta will be y by x. So theta will be tan inverse of y by x. This is equal to alpha. Now let us represent argument of the complex number by alpha. So if you are in the first quadrant, the angle theta will be equal to alpha. The argument of the complex number will always lie between theta minus pi to plus pi. It cannot touch minus pi, that is theta is open on minus pi and closed on pi. Now let us come to the second quadrant. Initially we have shown that the complex number, now the same point P is taken to a position P dash. This point P is taken to a position P dash. Now this point P is taken to a new position P dash. Initially this point P, when connected with origin O, makes an angle of theta, and this angle theta is given by tan inverse y by x. If we take this point P to P dash, then the angle this will be same, and theta can be represented by tan inverse of mod of y by mod of x. Mod of y by x. Now if we are in second quadrant, the argument of the complex number will become this angle, that is alpha will be equal to pi minus theta. This equation is for first quadrant, this is for second, third and fourth quadrant. Now similarly, if we come to third quadrant, the argument will become theta is equal to pi minus alpha with negative sign, that is theta will become alpha minus pi. And in fourth quadrant, theta will become minus of alpha. That means if you are in third or fourth quadrant, that is the argument of the complex number, Z will always be less than 0. So this is for the third and fourth quadrant. If argument of Z is greater than 0, that means you are in first and second quadrant. If argument of Z is equal to 0, that means complex number is purely real, that is Z is equal to Z bar. If argument of Z is equal to pi by 2, that means complex number is purely imaginary, that is Z plus Z bar is equal to 0. Now there are few properties of argument, that is first one is argument of Z1 plus argument of Z2 is equal to argument of Z1 into Z2. Argument of Z1 minus argument of Z2 is equal to argument of Z1 by Z2. These are the two properties of argument. Let us do some questions based on argument. Now we are given, let Z1 is equal to 10 plus 6i and Z2 is equal to 4 plus 6i. And if Z is a complex number such that argument of Z minus Z1 upon Z minus Z2 is pi by 4, then prove that mod of Z minus 7 minus 9i is equal to 3 root 2. Let us come to the solution. We are given argument of z minus z1 upon z minus z2 is equal to pi by 4. Now, argument of z minus z1 minus argument of z minus z2 is equal to pi by 4, because we know the property that argument of z1 by z2 is equal to argument of z1 minus argument of z2. Now z minus z1 is equal to x plus iy minus z1 is equal to 10 plus 6i is equal to x minus 10 plus I times of y minus 6. So argument of z minus z1 is equal to 10 inverse of y minus 6 upon x minus 10. Similarly, argument of z minus z2 is equal to argument of x plus iy minus 4 minus 6i, that is argument of x minus 4 plus I times of y minus 6, that will be equal to 10 inverse of y minus 6 upon x minus 4. So 10 inverse of y minus 6 upon x minus 10 minus 10 inverse of y minus 6 upon x minus 4 is equal to pi by 4. Now we know the formula, that is 10 inverse of x minus 10 inverse of y is equal to 10 inverse of x minus y upon 1 plus xy. Let us apply this formula in the given problem. So it will become 10 inverse of y minus 6 upon x minus 10 minus y minus 6 upon x minus 4 divided by 1 plus y minus 6 square upon x minus 10 into x minus 4. This will be equal to pi by 4. So this will become 10 inverse of y minus 6 into x minus 4 plus minus x minus 10 divided by x minus 10 into x minus 4 plus y minus 6 whole square is equal to pi by 4. This can be written as y minus 6 into 6 divided by x minus 10 into x minus 4 plus y minus 6 to the power 2 is equal to 10 pi by 4. So 6y minus 36 will be equal to x minus 10 into x minus 4 plus y minus 6 to the power 2. That is 6y minus 36 is equal to x square minus 14x plus 40 plus y square plus 36 minus 12y. This is equal to x square plus y square minus 18y minus 14x plus 112 is equal to 0. If you make it a perfect square, then x square minus 14x plus 49 plus y square minus 18y plus 81. This will be equal to 18. That is x minus 7 whole square plus y minus 9 whole square will be equal to 18. And if you take the square root, then it will become x minus 7 square plus y minus 9 square is equal to 3 root 2 to the power 2. You can also write it like this: mod of z minus 7 minus 9i is equal to 3 root 2. Now let us come to the example 2. That is, if argument of z is less than 0, then argument of minus z minus argument of z is equal to, if argument of z is less than 0, then the argument of minus z minus argument of z, a part is pi, b is minus pi, c is minus pi by 2, d is pi by 2. Let us come to the solution. If argument of z is less than 0, that means complex number is either in third quadrant or in fourth quadrant. That is first case 1. If you are in third quadrant, that is in third quadrant, the argument of the complex number will be alpha is equal to minus pi minus. So argument of minus z minus argument of z will be equal to, if you are in third quadrant, then minus z will lie in the first quadrant. So argument of minus z will be theta and argument of z will be theta minus pi, that is theta minus theta plus pi. So it will become pi. That is, I'll again explain. If you are in third quadrant, if z is in third quadrant, then minus z will lie in the first quadrant. So argument of minus z will become theta and argument of z will become theta minus pi. Then theta minus theta plus pi, that will become pi. Case 2. If you are in fourth quadrant, that is, if z is in fourth quadrant, then minus z will be in second quadrant. So argument of minus z will become pi minus theta and argument of z which is in fourth quadrant will become minus theta. So argument of minus z, that is pi minus theta minus of minus theta, that will become pi minus theta plus theta, that will cancel out, that will become pi. We come to the next example, that is if z and w are the two complex numbers such that mod of z is equal to mod of w and argument of z plus argument of w is equal to pi, then z is a w bar, b minus w bar, c w, d minus w. Let us come to the solution. If we take z is equal to r cos theta plus I sin theta, that is complex number in polar form, and w is equal to r cos phi plus I sin phi. That means mod of z is equal to mod of w. That's why we have taken modulus of z and w both as r. Now we are given theta plus phi is equal to pi. That is argument of z plus argument of w is equal to pi. Now theta can be written as pi minus phi. If you put the value of theta in z, then z will become r cos pi minus phi plus I sin pi minus phi. We know that cos pi minus phi will become minus cos phi plus I sin pi minus phi will become sin phi. So z is equal to minus r cos phi minus I sin phi. Cos phi minus I sin phi is equal to omega bar. So z will be equal to minus omega bar. Polar form. That is, if z is equal to x plus iy, we can write x plus iy in a polar form, that is r cos theta plus I sin theta. So if we can compare, r cos theta can be written is equal to x and r sin theta is equal to y. If we square and add these two equations, r will be equal to, that is x square plus y square. So r will become root of x square plus y square. Here we can write cos theta will be equal to x upon root of x square plus y square, and sin theta will be equal to y upon root of x square plus y square. The theta will be taken which will simultaneously satisfy the given two equation, that is cos theta is equal to x upon root of x square plus y square and sin theta is equal to y upon root of x square plus y square. Now let us take an example, that is if 1 plus I root 3 is given and we have to write this complex number in a polar form, that is r cos theta plus I sin theta. Now let us compare, then r cos theta will be equal to 1, r sin theta will be equal to root 3. If we square and add these two equations, then r square cos square theta plus sin square theta will be equal to 1 plus 3, that is r square is equal to 4, that is r is equal to 2. If we put the value of r here, then cos theta will be equal to 1 by 2 and sin theta will be equal to root 3 by 2. From these two equations we will get theta is equal to pi by 3. So we can write the complex number in polar form, that is z is equal to 2 cos pi by 3 plus I sin pi by 3. You can also write it like 2 into e to the power I pi by 3.